Hello, my name is Renan Lima Baima, and I'm here to present you the work entitled Modeling Objects Affordance via Reward Functions. I'm one of the co-authors together with Professor Stella Colombini. We are from the Institute of Computer from the University of Competence at the Laboratory of Robotics and Cognitive Systems. So a brief summary is that with introduction, right after the objects here that we achieved what is affordance and in how to present it and how what it brings to the table to aiding our research, the results, contribution, discussion, conclusion, finally the biography. So firstly, what we wanted to achieve here. Cognitive robotics proposed to create an artificial intelligent robot to learn from and respond to real world stimulations. So we wanted to achieve that. How we wanted to achieve that? There are a few possibilities and approaches. The traditional solution is working with physical parameters and in a specific scenario and action. This is not practical nor a scalable solution. So the other approach that are one of many, of course, it's working with object affordance. It allows to the restriction of the action space scope uh, by aiding the agent to focus in the one action and not just one action, but in the objects and learning autonomously the action. Why we choose that way? Because humans behave the same way. We apply similar structure techniques to obtain similar cognitive development. So our goal here was to develop a framework for learning affordance in which the reward function model the affordance and the robot learns then by interacting with object via reinforcement learning. Our framework was developed. Also, we worked with this incremental formulation of affordance via reward function, and we assessed if a more complex affordance could could achieve and be reused to solve simpler tasks. So, what is affordance? Affordance was briefly first introduced by Gibson. It defined as affordance as a list of actions that one agent can apply in an object. So, also right after, Gaver give another definition working with three categories of affordance: the perceptible, the hidden, and the false affordance. In other words, the object affordance exists whether it is perceived or not by the agent. And the interesting part here is that affordance brings this triplety of interaction between object, action, and effect. In other words, it's pretty similar to MDP, right? And there are few affordance they are classified, and we are using the spatial affordance, which is learning where the agent, the object is, and to interact with the place it is in which it is applied to. And the semantic affordance, the knowledge by itself, and what can we use that object for. Affordance in robotic tasks is a survey that shows that tries to classify any methodologies according to their generalization capabilities. And there are a few similar works that applies affordance to the same way as we did. However, our work differs from the proposal of them because they apply an imitation for human demonstration. We didn't use that. As you can see here, it tried to classify a lot of works, and of our works regarding the other ones, we are the only one not using visual input and also working with this try arrow technique. For materials, we use ViRep. It is a simulation environment, and we apply the humanoid robot now, a table and a sofa in which the robot is set on right in front of this table, as well as the RL kit toolkit. So our structure of it's separated by an epoch and steps. So in each epoch, The robot takes 250 steps, and every time the epoch is started, the robot resets its position and the arm's position, and not just the arm, the whole manipulator's position. It observes where it is. We use the SEC algorithm that give a random action, and this action leads him to different rewards, and each reward the SEC algorithm tries to get the best rewards out of that. And in every steps, it in every 250 steps, it resets and restarts a new epoch. So here we varied the geometric form. Sometimes it was a sphere, sometimes a cubic form, sometimes a cylindrical form. We resetted the position of the object and the size. Sometimes it was small, sometimes it was big. So what was our observation space? We took all the joints of the robot, just the upper joints, because we are just working with the hands and arms. The coordinates from both the robot's perspective and the objects, the joints, let's episode's position, the collision status, and the object size factor. Regarding the affordance relative observation inputs, we used the object's overall collision status, the Pound's end distance, the object's catchable status, the object if the object was caught status, which is regarding the releasing affordance that we didn't want to have that, and a prior open hand information. Regarding the object reward function, we had this 6 affordance, which is the perception, interaction, touching, grasping, grab it. Each of those affordances we gave a reward relative to this affordance. As well, we work with penalties. If the object was not caught, if there were no interaction, if there were no palm's hand, the palm's hand distance with the object, and if the object was let go. So what happens if we don't use our approach? Sorry. Uh, Basically, when you just give the grasping affordance, this 250 steps that we choose, the robot wouldn't learn effectively what we wanted. And what happened when you use our approach with this incremental strategy, all in all forms, with a cubic and cylinder sphere, it got to learn the affordance, both the touch affordance as well as the grab affordance. So when we try to apply the policy of of a specific form to other forms that were not known, to different sizes and so on, it also got to work and use the object that it was not known, it was not trained with. However, of course, when it was applied to the object that it was trained with, it got best results. But in the case of the cylinder, due to this flat side and rounded side, and when this policy was applied to the cubic form, it got even better results. So what happened here is that the space where this is a map, which means that the red it is, the more frequent was these many steps that it took, and the bigger the dots are, the more steps that it takes. So as you can see here, they all in all cases they achieving the affordance. It didn't took much, and also it got to work in closer to the center of the table. The further it took more time, more steps, and more time to achieve it. So how it behaves was this is an example of a sphere. It learned that when you touch the sphere, it starts to rolling, and so you can use the other hand. And when we apply that to the cubic form, the cube didn't behave the same, so it had a little trouble with that. However, it's still looking and try to search for the cubic form and achieving the affordance. Regarding the grasping in place, it was the same thing. The same happened. The sphere worked better with a sphere, the cubic with cubic. The cylinder against the cubic form, it got way better. And also how it behaved. However, when we said regarding the cubic grasping part, it got to generalize a little further from the center of the table. So it learned it even better. And the behavior, it learned to grasp the objects. So when there are of course a few failure here. Sometimes the robots try to grasp the object with both with all fingers closed, so it didn't allow him to perceive the touching in the palms of his hand, and also uh, with trying to then generalize to different forms. That thing that I said, that a cubic form doesn't have this rollability, this rollability affordance. The robot didn't learn it to grasp the cubic form the same way as in the spheric form. So, in discussion conclusion here, there are a lot of ambiguity regarding how affordability affects text. There are lack of standardized metrics for evaluating robotic tasks. And further analysis is obviously needed and necessary here. Maybe using a more robust structure such as a cube with the visual input would might lead to a better success rate. And it can deepen interdisciplinary cooperation and aid us to handle more complex behaviors with incremental learning. As you can see here, we are still working on that, and we also achieved the raising affordance. Uh, it both got to learn using a tool such as his chest. He learned that pushing against his chest, he could learn to raise the object easier, and also trying to grasp the objects with both hands and single-handedly. It got to learn. So this is the biography, and I thank you so much for your time and attention, and I wait for your questions. Bye.